Time class. We're going to go over more simplifying radical expressions. So remember, radical expressions are when we use the sign that looks like a square root sign, but we really refer to it as being radical. Sage purchased a caravan that has a square window, okay, as seen right here. I'll just shade it in. With a side length x. If the window has an area of 144 inches squared, write an expression to represent the side length of the window. Then simplify the expression. So we can write this as it's the square root of 144. So this becomes 12 inches, okay, because it's square. So 12 times 12 gives us 144. Square roots are examples of radical expressions and are often used when solving quadratics. An expression with a radical sign, if no root index is shown, such as the square root of 49, it is assumed to be 2 or a square root. So the root index is right here. So this what we have noted as n, that is a root index. So when there is no root index with a radical sign, we assume that it's 2, okay, meaning the square root of. If it's the cube root, then this root index would be a 3, and so on. But normally, most of the time, we're going to see it as just square root, meaning there's not going to be a number here for the root index. That's what we see most often in this class, at least. And then this right here is called, this symbol, looks kind of like a check, is called the radical sign. And the number that is inside the radical is called the radicand. Just a little vocabulary. When simplifying a square root, list the principal or the positive square root, because there could be a negative square root also, but we're going to stick with the principal or positive square roots. To simplify radical expressions, we can use the product property of square roots shown below. So assuming a and b are positive real numbers, the following is true. The square root of ab is also equal to the square root of a times the square root of b. All right, using the fact that the square root of 100 equals 10, rewrite 100 as a product of perfect square factors to demonstrate the property. Okay, the square root of 100 is the same thing as the square root of 25 times 4. So we see that noted like this. These are two perfect squares. So we end up getting square root of 25 is 5, and the square root of 4 is 2. 5 times 2 just gives us 10. Okay, we knew that already, but this is just an example of how we can break that down, because sometimes it's not so obvious. Sometimes it's something more complicated, but we can break it down as the product property of square roots. So we'll do a few examples. A square root radical expression is simplified when the radicand, or the number inside the radical sign, has no perfect square factors. Okay, the square root of 15 is in simplest form because none of the factors of 15 are perfect squares. So think about the factors of 15. I'll just write them down here. We got 1, we got 15, we got 5, we got 3. Are any of these 4 numbers perfect squares? Okay, none of them are. Therefore, we can't break this down anymore. This is already simplified. The square root of 15, that's as much as we could simplify it. The square root of 12 is not in simplest form because one of its factors is a perfect square. So let's list the factors of 12 here. We got 1, we got 12, we got 3, we got 4, we got 2, and we got 6, okay? If we use 3 and 4, because 3 times 4 equals 12, one of these factors is a perfect square. Okay, So that means this can be simplified even more because we can reduce this 4, the square root of 4, into just 2. Okay, so one of the factors was 4, which was a perfect square. Okay, complete the table of perfect squares as a reference, then list the factors of each radicand in 1, 2, and 3. And determine if the radical expression is simplified. Okay, is it simplified, or can we reduce it even lower? Okay, or can we simplify it even more? So let's just go with the perfect squares here. Perfect square of 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. Okay, let's list our factors for this one. We can go 1 and 27. We can go 3 and 9. And those are all the ones I could think of. I think that's all there is. Is it simplified? Meaning, is there any perfect squares we can pull out of this? Well, we know that 9 is a perfect square because 3 times 3 equals 9. Okay, because there's a perfect square here, this isn't simplified yet. It's not simplified. We could break it down some more, okay? It will reduce lower, okay, because there's a perfect square as a factor. Now let's list the factors for 38. The square root of 38, we have a 1, we got a 38, and we got a 2 times a 19. Look at these 4 numbers. Are any of these perfect squares? No, they're not. So this is simplified. It doesn't have any perfect squares to break down, to reduce. Looking at 125 here, what's the factors? We got 1 and we got 125. We got 25 times 5. And, well, I could just tell right off the bat here. I don't know if there's any other factors here, but I could tell just looking at this. We do have a perfect square here. 25 is a perfect square. Therefore, this is not simplified. And this will reduce even lower because we do have this perfect square. Okay, let's look over at the back. And yeah, just do a little vocabulary with you before you finish the rest on your own. We can use the product property of square roots and our knowledge of perfect square factors to simplify radical expressions with the steps below. Find the largest perfect square factor of the radicand. Rewrite the radicand as a product using the perfect square factor and the product property. Take the square root of any perfect square. Okay, simplify the square root of 24. So this will break down into the square root of 4 times the square root of 6. Is there any perfect squares here? Yes, there is. Square root of 4 will equal 2. So that's our final answer. 2 times the square root of 6. We cannot reduce this 6 anymore because none of its factors contains a perfect square. Okay, 2 times the square root of 6. That's it. Okay, let me just do one more with you. Use the steps above to simplify each expression in 4 through 6. So let's break down 48 into its factors. We got 1 and we got 48. We got 12 times 4. Yeah, what else do we have here? We got a 6 and we got an 8. Okay. We have a 4 and we have a 12. Okay, 12 will break down again. Okay, so we break it down into the square root of 12 times the square root of 4. Okay, and we could break down that 12 even more as the square root of 3 times the square root of 4 times the square root of 4. See that? Okay, we split it up this way, and then we know that 12 can factor even more. Square root of 3 times the square root of 4 times the square root of 4. And now we're going to simplify our perfect squares. And this square root of 3 cannot be simplified, but this square root of 4 can simplify into 2. This can simplify into 2 also. 2 times 2 gives us 4. And I'm just going to bring this square root of 3 to the other side. Bring it over to the right side. And this is our final answer right here. 4 times the square root of 3. Okay, so finish the last few examples on your own and bring me questions that you have to class if you have any. Thank you.